The railroad has sandbagged its track so that the floodwaters couldn't go further down the track. This is in Council Bluff, Iowa. The railroad feeds this big complex down here, and they've already evacuated and is doing flood preparedness work. This is how man does it. Sandbags. Nebraska power plant. Nuclear power plant. All the vital equipment's been surrounded by AquaDams. Administration building, and below that is the training building. This is a push-up dirt dike, and then they line the front of it with plastic sheeting. And they've put up miles and miles and miles of this. This was done privately by, I suppose, this company here called Kelly Ryan. They're right on the river. This is actually the bridge going up and over the Missouri River. Stevensville Elementary School.
need my 12 more sandbags right here. My 12 more right here.
Now 12 more sandbags.
Two people come back here.
What about all these staples on the ground?
Two people right here.
Huh?
Okay.
There's about 100 staples right here on the ground.
One up here. One up here. Okay, that's probably what we need right there for a corner.
Hey, you want to put a sandbag against this door right here?
I think we should. Okay, sure. Go that way.
Do that one right there.
There!
I'll cover up a corner.
Okay, spread the dam apart.
Hey, hey, you got
Hey, we don't have to move the trailer. It's okay. Hey, you gotta move that trailer?
We have some.
Just kind of pick it up a little bit.
See, well, if I put her over there, we're already out of room.
This side.
Yep, going now. Good job.
You get enough water pressure, it's gonna go no matter what.
Oh, yeah. Take a little longer.
Maybe it gets better.
With a mean puppy goes, she's horrendous.
Hey, she protected.
Mark left.
That's true, man. You don't do it one way.
Yeah.
Take a picture of the back of that.
I think you want to put fiber. I'll turn it back on.
No, we're just working like that. We don't need it. Let's let it be
Pull it back and back and forth.
No, where's that work? Now, let me get the work. Get out of this. No.
Yeah, but it wasn't as good.
Big game.
And this is a baby. They go up to 8 feet. This is what we have on the truck. And they go up to
is 16 feet.
He's got 120.
Does anybody own this Toyota? I do.
Where's the wire?
Go down. Go ahead and go down. Got it cleared.
Clear?
Fence is clear.
Alright, come on down.
Got to walk on the outside. It's firmer. The inside's got too many pleats. Come on, run back here. Good exercise, isn't it?
It works.
This is a 4 foot high by 250 foot long AquaDam. Turns the corner. And we're using a fire hydrant to fill it up, and the city's out of water. So we're waiting for them to recharge their water supply. This is the second of two 250 foot long AquaDams. In total, there is 900 feet of AquaDam, using 4 AquaDams. This is the connection for the second AquaDam, which is still being filled, but no water's going in it right at the moment. This is the first 250 foot long AquaDam. $250 foot long, 4 foot high AquaDam. It's got 2 turns in it, 2 corners. This is a telephone switching box for the city, and it was quite important to them. So we incorporated that in our design of the cofferdam that's going to keep the Stevensville Elementary School dry during the Mississippi flood event. This is in Stevensville, Louisiana. And what do you think of the AquaDam?
Pretty cool.
Pretty cool, huh?
It's fun to run on.
Yeah?
Yeah.
Well, you was a lot of help putting this in. Thank you very much. Back at Stevensville Elementary School. Putting in the last section of AquaDam, which is a 30-inch high by 160 foot long AquaDam. So far they've been pumping for approximately 5 minutes. Water's going into the AquaDam as we unroll it. The boards, of course, are to, because there's a crown, so the water runs off the highway. The AquaDam would want to roll off that crown, and we're compensating for it with the boards. Now we have the last AquaDam in, so the main body of the school has been completely surrounded. It's the Stevensville Elementary School. Into this AquaDam, and these are the 2 fill tubes to this AquaDam. Now they're ready for flood fighting. It's supposed to be able to take 3 feet plus of water depth. AquaDam.net 800-682-9283. AquaDam going between 2 fence posts. One here, the other here. Bent right around them. A 1 foot gap. Because the concrete is on a slant, we didn't want it to roll into this wire mesh, so we used these pallets to keep it off the wire mesh and on the high ground, which would be next to the building. AquaDam is barely touching the walls on each side now that it's full. Going down this hallway. Makes it 90 degrees. Turn. Looking back down the corridor, making the turn. $850 feet of AquaDam, approximately. Hopefully this helps that out. This is the Syracuse Levee in Morgan City, Louisiana. This is where we started the AquaDam. The AquaDam is a combination of 3-foot high and 30-inch high AquaDams, 1 mile long. We're sitting up here on a levee. On this segment, we left some wood in because we got too far to this side of the levee. We got this side, too far this side of the levee. 1,000 feet that way. The stakes that we left. This one's leaning hard to the right, and the slope of the levee is not flat on top, and so the boards compensate for that. Where a 3-foot high AquaDam drops down to a 30-inch high AquaDam. There's 2,910 feet of 3-foot high AquaDam, and now we've dropped down to 2,000 feet of 30-inch high AquaDam. The 30-inch high AquaDam does not have a baffle in it. The 3-foot high AquaDam does. The connection between the 3 and 30-inch high dam. Where we had to artificially enforce this connection right here. They're not worried about this segment of the levee. The levee district isn't, because it's higher. There's 5,035 feet of continuous AquaDam. These are Hesco barriers filled with sand, and then a piece of plastic draped over the top of them. It goes over the top, down and out, and they got sandbags along the edge. They have miles and miles of these Hesco barriers up in Louisiana. Plastic's draped over, then they put sandbags all along here, but they didn't make them continuous. And the skirt that goes out in front is not very wide. Let alone, look how they tore up the slope here. It was all nice and green, but where the Hesco barriers stop, it's all dirt. They just simply tore up the slope to run the equipment up here to put the sand in the Hesco barriers. Miles and miles of Hesco barriers. Hesco barriers. This is a homeowner on the Missouri River, Mandan, North Dakota. Flood fighting. They had to do quite a bit of preparation work. Mainly, they had to remove all of this type of gravel. You cannot go over gravel like this. So they took out all the gravel, and then they brought in some fill material because it was sloped like that, and we had to level it off. We also have boards to use. This was a 200-some foot long AquaDam. Their boat dock. And this is the mighty Missouri at record flows, predicted to come up. Nobody knows how far.
Yep. Give me a second, I gotta kind of pick these up a little.
Now we're doing the other side. Pushing the fill tubes up.
That's about all you got on the side.
That's it.
How much you got up?
Plenty.
4 feet. Okay, excellent. It's the same.
Nothing good. Good.
I gotta pull it back a little bit.
Okay.
Just that.
Okay.
Okay, we are corner to corner on this. Let's try this back out.
Now that we have this end done, we're going to move and do the same to this end. Of course, normally we would fill up this AquaDam coming around that ends here first, and then make our connection. That's not going to happen here. These blocks are too steep. You don't want them that steep. Move them back so they're a little flatter like that. One block is 2 feet long, 2 feet long, 1 foot long. It makes the perfect little cradle for the AquaDam when you're starting it.
Which side? Outside? Roadside?
All of these blocks are going to be set with a little less of an angle. The blocks are for the slope. Here we are at a house in Bismarck. There's a lot of slope to his property, so he had to bring in fill. The AquaDam is sitting on fill. And then he put big sandbags in front of the AquaDam and then draped clear plastic over it. Put a lot of work into his cofferdam home protection system. Using a combination of big sandbags, little sandbags, sheet plastic, an AquaDam, 2.5 foot of fill material. This homeowner believes he's got the answer to what will help prevent his home from being flooded. The homeowner. We're filling in this last segment. This whole AquaDam's been filled up. We're using 3 separate AquaDams and well water. Using well water to fill the AquaDam. Three-foot high AquaDam. He's got this up to about 5.5 feet high, the top of the AquaDam from where he started. Well, you can see ground level, and it was severely slanted, so they filled it in the slope. Did a great job. All of this fill looks good, but of course has no will have no impact on the final event. If this fill would have been put behind the AquaDam, then water could have went right to the top and over the AquaDam. This way, I don't know what any of this does, except makes it flat, and good for an AquaDam to be up high, I guess. This is an installation in Bismarck, North Dakota, around a retirement community. We're starting off with a double closed-in 6-foot high dam through the low spot. We just started with 4 pumps. We have 4 3-inch pumps pumping into this AquaDam. Six foot high by 250 foot long. This is to close off this low spot here. The rest of the installation, except one piece, is a 3 foot high by 1,400 foot long combination AquaDams. We have yet to put these blocks up. We're putting a little padding next to this tree because we're going to go down it or slide up it as the AquaDam foot fills. These are blocks set up to compensate for the slope of the land. The AquaDam's going to end right here by this building. The AquaDam ends right here. If all goes right, here will be the end of this 6 foot by 250 foot long AquaDam. We've been pumping now for about 35 minutes. The AquaDam here is the low spot, of course. And the ends aren't even, water's not even to the other end yet. So the low spot seems to be at least 3 feet lower. Here we're untying the ropes here that are tied to the center strap. We've got a point right here, and we're afraid it's going to rip out here. It's got a lot of pressure on it, so we had to have that here so the AquaDam would fill up and stay in one spot while it was filling. Now we're going to cut that rope, or we're going to take the pressure off. Or by untying it if we can, but there's a lot of pressure on the knot now, or the slip knot we thought we had in it. So the AquaDam starts over here, the 6 foot by 250 foot ends right here. Then we're going to start this 3 foot dam. Run right along the back of these homes. we're going to cut this rope, but this is what it's going to do to the top of this AquaDam. Go ahead, cut that rope. Well, it barely moved, less than an inch. And now there's not nearly as much pressure on the secondary rope. So we're good to go. Okay, the 6-foot high AquaDam. Look at right here where the ropes are. We've cut all the rest of the ropes except at the other end. And this is really binding on that seam right here. We've decided that it's time to cut the slack. We don't want it to break our seam. And those aren't to hold the AquaDam. They're there just for us to make absolutely positively sure where this top seam is going to end up. And now we're going to untie this rope here, which is tied to a tree back over here. We've already got water going in this AquaDam here, the 3-foot high AquaDam that's going off the end of it. This is what's happened to the boards. They should have been pulled back here a little bit. They're going over sideways. That one there, here. Now the water pressure is going to push this thing, is going to push this AquaDam that way. And of course those boards are just to compensate for the height, the slope of the land here. We're reaching in the lowest part about 6 feet high. We've only got one pump running into this AquaDam because it's a long pump. So we didn't want to put out that much hose, so we're going back and forth with the hose. While this is pumping up, after a couple of minutes we're going to abandon this one, leave the pump running, and go install another AquaDam on the other side of the property. Okay, we have the 6-foot high AquaDam full. You can see this person looking at it right through there. Now we're going to add a 3-foot high AquaDam to the end, or the start of the 6-foot high AquaDam. Comes up through a connection collar right here. Yes. And now we're going to unroll this. Repositioning the AquaDam. There. Now we went straight through here so we could lean on the tree, even though this is a little bit lower than here, but we figure that tree, that's a big plus, leaning into that tree. So the rest of the AquaDam, there's the end of 250 feet. It's going to take 1,500 feet to go around this housing complex. This is is where this 3-foot by 250-foot long nice
Need some hats, man.
There, this is the end of this AquaDam. We have a connection collar starting here. It's stuck underneath this AquaDam. We've slid it on the top and we've made a double closed ended AquaDam so it comes up and sits on top of the 6-foot high AquaDam. Well, of course, it's only 3 foot high because it's 6 foot high down here in the low area. So this is a kind of special here. Way of connecting the end. And it runs 250 feet. There's the Missouri River. Here's the 3-foot high AquaDam abutting into the 6-foot high AquaDam. We're pulling out fill hoses because we're done filling the 6-foot high dam. We're going to leave one hose for a garden hose to put water inside the AquaDam. Oh, maybe one 3-inch hose too.
I'll leave that one 3-inch.
The connection. We're almost done with this installation. This is the 6-foot high AquaDam. And it's the next day. Starting with starting from the opposite side of the river, this is the back of the complex. It's where a 3-footer abuts into a 6-footer. Making the last connection on this side of the house until the floodwaters actually get here.
Which one's outside? This here? You show that other one after I get started? Well, that's a little bit too far. How's that? Alright. You got enough?
Got the plastic pushed to this corner, pushed to this corner. The fill tubes have come up through the top.
You got about 5-6 more inches on the side.
Now we're sticking the hoses down into the tube.
Want to leave this on?
And it has to go past this point so the water goes into the cavity of the AquaDam. And then another hose on this side. Then we duct, after the hose is put in, we duct tape the fill tubes up all the way to the end. And this is what it should look like after it's been duct taped all the way up. And now this side has to be duct taped. This AquaDam is the last AquaDam to be filled until the actual flood. And then this AquaDam, which is 5 foot high, will go across the gap here from that AquaDam that's filling now to this AquaDam, closing off the community. Well, this is the welcome mat to this house, and here the AquaDams are out the front door. Back door. We've got a 3 foot high AquaDam, double closed ended with the ends tapered on both sides so to reduce the amount of water. And this is where the 6 foot double closed end AquaDam, that's the first one we put in. And this is what it looks like. This is the front side of the property. Makes a 90-degree turn, goes right down in front. You can see the AquaDam, the 6 foot high AquaDam in the background, looking over the top of the 3 foot high AquaDam along the river. Of course, we're going to lean right into that old tree stump. Perfect for an AquaDam. This is the last segment that comes all the way around this house and ends by this white car over here. It's 350 feet long. This is lower here than back up the chain where we started from. So we took advantage of the high ground and put our AquaDams in accordingly. Made sure the connections are always as high for the next AquaDam as possible. You want to know where those connections are going to be so you can plan it out so it's not in a low area. In this area, they're going to dig a sump hole. After they determine where the gas line, the power lines are here, you can see them there, so they have to make sure they don't dig into them. They need to have a sump hole so they can set a pump up, pump the excess water through that's coming in under the ground, under the AquaDam, back over to keep the area dry. Here we are, rounding the corner. And back to the start.
Okay.
The only piece that doesn't have will be right here. The other one across there, the 3-foot high dam, is being filled. This is the last dam on this side. Then they'll have a watertight community if they keep the pumps running. This AquaDam is at a different piece of property. It goes all the way around the house and it butts into another sandbag levee system. You can see the levee system down there, and then this 3-foot high AquaDam. The AquaDam's clearly a lot higher than the sandbag levee system. They wanted to butt into the levee system here, so they were supposed to have taken the end, which is here, of the AquaDam. It's where the black outside dull material starts, that's woven, and put it 2-3 feet up and over the top of the sandbags. Well, they clearly didn't do that. And then they were supposed to shrink down the end of it with ropes, which they did do. So all in all, pretty darn good job. They should have got it up over the sandbags at least another 3 feet. And it goes all the way around the front of the house. This is the opposite homeowner's end. He started the AquaDam off a double closed-ended plug at the other end of this, and deadheaded the closed end here into the sandbag wall. We like this approach much better, and that way you can overpressurize the end. But both installations are super good. This AquaDam is on higher ground than this AquaDam is by about 4 inches, if you can see the difference in height. Oh, I see the Army Corps has come in with Hesco Barriers and come all the way around everything. Since the last time I was here, look at all the ground they tore up. Then they got the sandbag wall here, and of course that's not going to be a very high wall. It's too steep. I mean, it just goes straight up, straight down. Then they got a little footprint here. This one was way too short for this homeowner, but now the Hesco Barriers is certainly, but they're going to be in with everybody else. So there you go. This is another house. We had to sacrifice the pool. There's the river, just a channel of the river, a back channel. the front of the house. Here we're making the last connection, 20-foot long, little double open-ended AquaDam to connect to the end of these two. We're pulling the inside material corner to corner. The last connection. We go around this beautiful house. This AquaDam here has potential for more height. They stopped pumping it on it too soon, and they need to increase the height of it. We're not very far from the river. Well, I'm back to explaining this AquaDam here, which I started to, but got taken away, so this is out of sequence. So I've already explained about that end. That end is how they filled the AquaDam against those sandbags, and they didn't get it up high enough. Now what I want to show is the other end. This is the other side of the house. This is the closed in of the 3-foot high AquaDams. The owner thought this would be 3 foot high, these sandbags, and I tried to tell him that you need to go all the way around, that those sandbags are too low. The end came up and over this sandbag wall here, and you can clearly see how low this area is, or sandbags are, compared to the end of the AquaDam. The AquaDam came over the wall and ends right here. It should have been moved the other way 3 feet, and then it would have been much better. There's the end of the AquaDam. It comes all the way around the house and ends here. We don't particularly like this installation, but compared to this low wall, water goes over that before it goes over the AquaDam. Since then, the Army Corps has come in with Hesco Barriers and built a barrier all the way around this. Boom, boom, all the way around over there. The trouble is, they got low spots in them. Well, one low spot is right here. That's one of the lowest spots. Another low spot's way over there. You can just look around and see the low spots. But right here is also another low spot. So they're betting on the Hesco Barriers now and not their sandbags. Sandbag walls are the last resort. A lot of work in sandbags. Of course, this is clear plastic draped over the top of the sandbags, and I hope to keep the water out. A lot of sandbags made in a pyramid with one bag on top, where the AquaDam is one continuous unit. This is a garden area, very fancy. This is the intersection of Sandy Lane and Riverfront Place. We have quite a few homes here with AquaDams. We have a 30-incher around this house, and that's the one I'm going to show you next.
AquaDam.
Now you can say that.
Thank you, AquaDam. We highly recommend these people. Conscientious, kind, and understanding. We appreciate you.
This guy come up from Minnesota to help us.
Is that right?
Yeah.
Oh, well, they got the same problems, too much water.
Been there, done that.
Yeah. Well, what do you think about sandbagging?
Definitely nice to not be sandbagging.
Yeah, I bet it is. So, I'm going to walk right around your house right here with this camera, if you don't mind. Thank you.
Enjoy.
There's a little 30-inch high, severe hillside. You can see the slope of the top of that dam is like that. There's flat. Of course, we had to use these blocks to compensate for the slope. Here's a connection of the second, third AquaDam. Had to fit between those trees. If we were to go down here, we would have lost all of our elevation. So it had to fit between the two trees, and really we didn't want it pushing on the house. We had to block it up big time, and because it's on a severe hillside. And so far, works great. Trees didn't put a hole in it, and they've got a lot of use out of a 30-inch high AquaDam. This house is well protected, provided they keep their pumps running. Put plywood up along the wall here so that the AquaDam, if it touched it, would not hurt the siding. But the AquaDam isn't. It leaned down the slope like predicted, leaning on these trees. Beautiful job. We do this house, the next house, that house, two more houses down there, but now we're going down Riverfront Park Place. We was looking at that house, now we're looking at this house. Started out with a 60-foot 3-footer on high ground, and we've attached a 3-foot high AquaDam to it. It's still filling up. This is the same house. Water's already running out, coming up out of their basement pumps. Same house, backyard. Now we're going to look at this house. It also has a ring all the way around the outside. Hi. So, oh, looks great.
Having less problem than the neighbors are having, but
Oh.
come on.
All told, we have about 10 homes here in the community that we've done with an AquaDam. Since we put up the AquaDam, the Corps has come in and put a Hesco Barriers. I don't know what size Hesco Barriers these are, but this is a 3-foot high AquaDam. And I believe it's every bit as high as these Hesco Barriers are. This homeowner put up his AquaDam by himself and then left town. And it's not high enough. It could be brought up considerably. But he sandbagged it. He's happy. And now he's relying on Hesco Barriers and an AquaDam. This is where two AquaDams butt into each other. This AquaDam goes this way, this AquaDam goes that way, and they butt and overlap each other, making a great seal, watertight seal. Hesco Barriers. AquaDam. Now these neighbors were going to go all together, but this neighbor was low, so these houses, there's 3 houses that are all together. And we had to crib up the side of the AquaDam here. And now we're at this house. It goes all the way around this house and 2 more houses. When I did my preliminary survey, I also noticed that, as you can see by these Hesco Barriers, the low area right there, we had to avoid that or we would be losing our height. You can see the AquaDam over here is higher than the Hesco Barrier. That's why we didn't go through this area right here, because it was just a natural low drainage area, considerably lower than this homeowner got by putting the AquaDam right next to his house. Far superior. After the Hesco Barriers fail, he'll still have protection with his AquaDam. And of course there's the river. This ring dike around these, 4 homeowners is over 1,000 feet. Now through this area here, it was low, so we made the homeowner fill this area in to keep height. The Hesco Barriers do not do that. Now the Hesco Barriers are 4 or 5 inches lower than the AquaDam through this area. No, it was very important to keep elevation through this particular spot, which the AquaDam's installation did. The raging Missouri River. Through the trees, and down along the front of the houses. They had to fill in here with a little dirt because it was way too low. and then the AquaDam can sit on top of the dirt. We don't recommend that, but that's what it took place here. You see the AquaDam on the riverside. This is the AquaDam on the front of the house, the garage where you drive up with your car. The street side of the house. These homeowners have a dike all the way around them. This is where we started at, around the back of this house, where we have the 4 houses working together. This gentleman was in with them until it was pointed out he was too low, and the rest of the homeowners would be sacrificing their homes if they dropped to his level. So again, they made the decision that no, they couldn't do that. He would have to ring dike his, and these 4 homeowners ring dike theirs. Instead of all 5 of them, it was because this homeowner's level dropped lower than what here is, and that makes all the difference in the world. So elevation is everything. This AquaDam started with a plug right here, 20 feet long. One AquaDam goes this way, the other AquaDam goes this way, and they're still filling it. They overlap each other in the back. This homeowner has put up barriers here, Hesco Barriers and huge sandbags to make a perimeter for his elevated AquaDam, which is sitting on fill. And so he was worried about trees, because it's heavily wooded, that would come down and puncture the AquaDam. So he wanted a buffer between the AquaDam and the trees that could be moving out here in the floodwater. So this is a lot of work, put a lot of work into this. Well, this is the most elaborate thing I've ever seen go through an AquaDam. Now, in my opinion, I mean, geez. He's made a 3-foot high AquaDam into something that's about over 6 feet tall. So a lot of work, a lot of effort. And of course everybody was panicked, and they were predicting the high flows a week ago, and since there was added time, he just simply kept adding to it, and now he's got a huge barrier around his property, or his house. Has a garage, a workhouse, but which sits low, but he wasn't able to spend the time as he did his residence. But so he pushed up a dirt berm around it by scraping the ground, basically scraping his grass and lawn into a pile for flood protection. But he decided that he couldn't keep 2 places dewatered, so the garage he's not going to try and dewater, but his house he's got pumps, and that's where the fight is.